Hi, everyone. Well, let's give it a few minutes here as people continue to trickle in, and then we'll get to the main content here in a moment. Thanks so much for joining us today. For those of y'all who were able to join us last time, welcome back. For those of y'all that are new to this webinar series, welcome aboard. We're excited to have you. Today, we're going to be talking about Dataware, an emerging data architecture focused around integration and minimization. Dan, if you could go ahead and click through the next slide, we'll get into some introductions for those of you who haven't gotten to know us before. I'm Joe Hilleary. I'm a senior research analyst with Eckerson Group. And I'm joined today by Dan DeMers, the co-founder and CEO of Cinchy, who has worked to actually build a Dataware platform, Cinchy, and will be able to provide us with more concrete observations around some of the challenges of implementing this kind of architecture. For those of you all who are already familiar with Eckerson Group, I apologize. For those of you who are not, Eckerson Group is an industry research and consulting firm that specializes in data and analytics. You can see here some of our recent clients on the consulting side. And you can access any of our research content for free at eckerson.com. So I'd like to lead off today with a recap of a little bit about what we talked about in our previous webinar. So for those of you who were able to attend that, some of this may be a little repetitive, but for those of y'all who are just joining or who need a refresher, hopefully this is some good ground to set. So in our previous webinar, we looked at several different modern approaches to analytics, and particularly the data flows that correspond with that. So on the left of this slide, you can sort of see a diagram that shows what a traditional approach to analytics looks like. You have a bunch of applications. Each of those applications has an operational database that's storing the data used within those applications. And then when we want to do analysis, we bring data from all of those databases into a single repository, a data warehouse, a data lake. We went through a whole bunch of these last time, but the general pattern is the same, some sort of centralized location that allows us to access that data efficiently for business intelligence or data science use cases. Dataware, as we introduced it last time, sort of upends this paradigm. Central to the idea of analytics is this idea of bringing the data back together, right? We've got data that's fragmented in all these different application silos, and we need to bring it together using integration. But Dataware takes a different approach. It says, what if we never separated the data to begin with? And so the central idea behind Dataware is to reduce integration by removing those application silos from the beginning. You're not having to integrate, you're not having to bring things back together because it was never separate to begin with. So with the Dataware paradigm, we have sort of this shared data backend where applications are running directly on top of one uniform layer, able to edit and interact with that simultaneously. And so because the data is already unified, we can also do business intelligence and data science directly on that shared backend. We don't have to bring it anywhere else. We don't have to bring it together. We can access it directly. So that's a little bit of context for those of you all who are just joining us. Today, I'm excited. We're going to dive a lot more into what Dataware is, how it functions. And so to that end, we're going to be looking at, if you can flip to the next slide for me, Dan.
Sure.
Sort of the 5 basic attributes of a Dataware platform. And so for each of these, and this is one of the reasons I'm really excited to have Dan here, we're going to talk about, the capability, and then Dan's actually going to be able to walk us through some of how Cinchy has managed to implement these concepts within their platform, which I think will really make this a lot more tangible. So with our first attribute, a Dataware platform needs to have both reading and writing capabilities. So if you can flip to the next slide, perfect. This should be fairly intuitive, right? So when we're talking about Dataware, we're talking about a repository with read and write capabilities. I need to be able to, as an application, go look at data, use that data in the process of day-to-day operations. But I also need to be able to create new data, right? So if I have an application like a CRM, I need to be able to create new lines within that CRM. I need to be able to add companies, individuals. And I need all of that to go into this shared repository. So when we talk about the read-write, there's a couple of different ways that manifests. Data access, we talk about it in terms of applications need to be able to access this, right? It needs to be something that a developer can tap into as they're building out new applications. But we also talk about access in terms of human individuals. So if I'm a business analyst, I also need to be able to access that data in order to kick off my own workflows. Maybe I'm building a dashboard. Maybe I'm pulling together some queries. I need to be able to access that as a person, not just as an application. And then when we talk about writing or recording new data, that happens in two different ways. So on one level, we need to be able to indirectly access data. And that's similar to the example that I gave before, right? So imagine, an application that you interact with on a day-to-day basis. You don't want to be having to go into this sort of data backend to make every new data entry. You want to be able to use the user interfaces that go along with that application, right? So if I've got, a tool that I'm using, I need to be able to generate new records in the backend that's shared across all of the other applications of my business from each of those tools. So I can make this sort of indirect record where I'm using an application to write that record. And then with Dataware, again, because it's sort of solving on two different sides of the equation, both the software development side and the analytics side, I need to be able to directly access too, right? So as a person, I should be able to go in and actually create a new row in the sort of backend schema without the need for sort of a UI or application interface in between me and that data layer. So we're talking about indirect and direct access. And Dan, this is where I think we can kind of get into what for me is much more exciting, which is to look at like kind of how these things work in principle, because I can talk about it, but Dan has lived it. So Dan, I'll turn it over to you here for a bit. Can you maybe talk to us a little bit about what that looks like, how it manifests within the Cinchy approach to Dataware?
Yeah, and just for everyone who's joining, and again, happy to be here today. So thanks all for joining. But keep in mind, I'm going to be showing how inside of the Cinchy platform, we've implemented these capabilities, but I am hoping that this content is valuable beyond that, meaning regardless of what Dataware platform you ultimately move forward with, or if you're building your own, the core concepts are the same and they may be implemented in a slightly different way, but it would need really to exhibit the same kind of raw capabilities. So when we think about data access and read and write, because it is straddling the analytical and transactional world, of course, apps don't just read data, they do create data, as Joe mentioned. So if you think of inside of a Dataware platform, which often does feature the data fabric at its core to provide that universal view of data. So here you're seeing inside of the Cinchy platform, we're seeing all the different data sets. This is just in our environment, and I'm logged in as myself, and I'm just looking at our production environment, and it's filtering everything down to what I have access to. But every circle that you're seeing here, every dot is a data set that has tabular data, and inside of that tabular data may also be unstructured or semi-structured data, and you're seeing all the relationships between that. So the ability to discover data, go into the data, and see the data is one thing, but often you'll need to be able to change data. So for example, if I go into, I have a sample data set that I created. So there's one called sample data set. So I can locate that on the fabric. I can go into it. I can, of course, see the data. Right now I'm using the end user experience that's metadata driven, and I'm looking at it in a tabular view, but I can make changes to that. So I can change Joe Schmo's last name, Joe Toe, and that change is saved. I can add a new record. I can even go as far as to create an entirely new data set from scratch and manage access and connect that data set to this data set or to other data sets. And I'm able to do that in a shared environment such that I'm not stepping on the toes of other teams, be them development teams or business teams that are also in the same way using this to access and change data. So the ability to do that programmatically, the ability to do that through an end user experience is a critical requirement if ultimately what you're looking to do is avoid use of application specific databases. It needs to be a superset of those capabilities.
Absolutely. And I think you raise a good point there, Dan, that's worth reiterating. We're going to be looking today at some examples for the Cinchy platform, but sort of these core aspects are universal as you think about Dataware more broadly and some of the other ways you might implement that, either different vendors or building your own. These are sort of universal attributes. So we're just going to be looking at one way that's been implemented. And Dan is in a great position to sort of explore some of those design options around sort of how do you do all of these things that we're talking about within a Dataware platform. So the next piece, you may be thinking, okay, well, that's great. I've got all of these applications and all of these people accessing my data. That sounds like a nightmare. I don't want all these people making edits. That's why I lock down my data. That's why I want people only reading things. If I've got business analysts and software all sort of working together on the same data, my data is just going to be a mess, right? And so that's where what I think is really one of the core technologies that's unique to Dataware comes into play. And it's this idea of data collaboration. And so what data collaboration consists of is the ability to edit in real time to rectify versions in real time while supporting multiple entities editing that same shared set of data. And so a good way to think about this, I think by now most of us have probably used Google Docs or some sort of other cloud editing software, right? So, I may have a document shared with my colleague. We're, working on a paper together. And I can write a paragraph at the same time my colleague writes a paragraph. And we can edit and work on one document in real time, seeing each other's edits without overwriting them. And so it's having that real-time ability to handle multiple users, handle multiple edits, and sort of make sure that the present version is representative of all the changes that have been made. But doing that at a transactional scale that supports transactional data, supports operational workflows, and supports human and non-human entities is really a step up from that example if you think about like a Google Doc, right? And so that's where the heart and soul of some of these Dataware platforms is managing that problem. And so Dan, I know Cinchy has come up with some ways to address that. I wonder if you could share some of those.
Sure. Yeah, and I think like when people are new to the concept of Dataware, some may jump to the assumption that it's basically like a multi-tenant database that can be used simultaneously by multiple applications. Well, it is, but it's much more than that. And really the idea of collaboration is the much more, because it's the capabilities that are not built into modern persistent stores because they were not designed for collaboration. They were designed to be used by software, not by people or multiple pieces of software built by different development teams. Some you buy, some you build, and facilitating the collaboration on that. Otherwise, it would be chaos. And that's where the data collaboration capability really needs to enable that collaboration without the chaos. So to utilize things like domain-driven design and governance and whatnot. So what I'm going to do is I'm going to show you an example of a connected system and show you legacy applications and humans, as well as external APIs, all collaborating on data, in some cases in real time, in other cases in near real time. And I'll kind of explain that. And I'm going to use Salesforce just as an example. And I'm in a Salesforce environment, and this is just a sandbox environment. So I'm just going to create a new contact inside of this. And I'm going to just add myself here. So I'm Dan, that's my last name. I'm just going to pick a dummy account here, and I'm going to put an email address here. And I'm going to go ahead and save that record. So I've created basically a record inside of a traditional application, but I've connected that via the fabric into our Dataware platform. So if I collapse out of this data set and zoom out, again, there's our entire universe of data based on what I have access to. So let me find the data set called people. So I can see that that is in a domain called contacts, which has other related data sets. But let's go into the people data set, where I'm going to see by default a tabular experience on that data. And you can see there's the record that I just created, where it was against ABC Inc. as the company. There's me, there's an email address. And notice that some of the fields are read-only, some of them are editable. And you can see I was just doing a test just to make sure everything was working before the demo, which is the record immediately before that. And I can even change some of this data. So I'm going to change this, instead of doing CEO as I did in the record below, I'm going to say CTO, just as an example. So I'm going to make a change to the record via the Dataware platform, and I would expect that change based on my access to then flow back into the system of origination, in this case, Salesforce. So if I come back into Salesforce and just reload the screen and go to the details, you'll see there's the myself that I had just created, and there's the title of CTO, which was blank before, but I can actually change that here. So let me just go back and edit it. So I created it in Salesforce, I modified it via Dataware, and now I'm going to modify it via Salesforce. And I'm going to go ahead and save that record there. And if I go back into this view here, and if I just reload, then what I'm going to see is that the record is now showing CEO. But what you may have also noticed is, if I go back to Salesforce for a second, is while I typed in nothing more than my name, my email address, and then eventually the title, notice that a phone number is there, notice that a mailing address is there. There's some other fields here that I did not type. So where is that coming from? Well, via Dataware, which benefits from data collaboration, I can see the entire lineage of who the collaborators were on this individual record. And this record is originating from Salesforce, but you can see it's blended seamlessly with data from multiple sources. So I can look at the collaboration log and basically look at every collaboration event on this record. So I can see it was created by myself via Salesforce at 2:14 p.m. I'm in Eastern time, and you can see the values that were there. Then a separate agent was hooked up to Dataware, which is not connected to Salesforce. In this case, it's an application called ZoomInfo. And what it did is it found my profile photo, phone number, address information, and a bunch of other things. And it then added that to the record and then fed that back into Salesforce. And then I went in and I made a change. If you remember, I changed the title to CTO. And then via Salesforce, I changed the title from CTO to CEO. So it's kind of like Git for data, but inside of a dynamic schema. And this is just a little example of people, applications, collaborating on a single record. Now imagine this at scale for multiple records in a single data set and multiple data sets where it's controls that are limiting what every individual person or piece of code can see or change down to the data cell level. So hopefully that gives you a taste of the idea of data collaboration, which is kind of weird and wacky for people when they're first experiencing it, but it makes a lot of sense once things click.
Yep. And so I think that's great too. I'm glad you showed us the sort of version piece there where you can sort of track that history. I think that's sort of critical to this ability is you need to understand what changes were made by what when, or you just don't have any sort of governance in place.
Yeah, and in that case, even the system that's connecting in to Dataware may not have those inbuilt capabilities, but as you can see there, Dataware adds it, it normalizes it, it universally applies those controls and the collaboration capabilities to all data, regardless if it's originated in the platform or if it's connected to the platform.
Absolutely. And we actually have a question coming in from Kunal, who asks, can data edits be routed into a workflow to govern updates with approvals before being applied?
They can, yeah.
Kunal, if you don't mind, we get to that. There's another slide in here where we'll talk a little bit more about approval processes and some of those things. So it might make more sense to answer that then, but I see you, we'll get to you. And so if folks have other questions, feel free to ask them on the relevant slide. We'll also have time at the end for Q&A. So the next sort of piece we want to talk about is this idea of operational base. And this is really what makes Dataware very different from a number of different solutions in the analytics space. If you followed Eckerson Group for a long time, you know that's sort of what we focus on. And if you were even here for our last webinar, that was a lot of what we focused on, which is that idea of, okay, I'm bringing data together for business intelligence or data science. And, you know, the data warehouse is sort of the quintessential early version of that. But the idea of just sort of, this is a repository of data, it's being fed from applications, and then I'm working on top of it. It's, you know, much more one directional. We don't have that sort of same write capacity. But Dataware, while it can be used as an analytic base, as we'll get to in a moment, critically is also an operational base. And this is really the starting point, I would say, Dan, and you can feel free to disagree with me, but sort of where Dataware comes from. It's solving this problem around, okay, on the operational side, on the software side, we have these application silos where each piece of software comes with its own operational database that's being used. And that creates this initial segmentation of data from the very beginning, because data originates in the software, it originates in the applications. And while analytics came along after, you know, folks started creating these applications and realizing you could repurpose that data, everything sort of within that space has been an attempt to patch and to work around some of the initial design choices that were made before analytics was really something anyone was thinking about. And Dataware is going back and sort of reimagining how we might approach software, which then subsequently has all of these different ramifications for analytics. So when we talk about the operational base, a Dataware platform really needs to be able to replace the individual operational databases of applications. I mean, that's sort of the heart and soul of it. It's the shared data backend that's capable of supporting transactional workloads. So, you know, Dan's referenced the idea of a data fabric a few times, and we dug into that a little bit more in our previous webinar. I think there's a recording of that as well for those of you who missed the first webinar but are interested in going back. We did a comparison of a bunch of different approaches to analytics architectures. But with the Dataware approach, any new application doesn't need a database. If you're building an in-house application, you can just build it directly on top of a Dataware platform that will use the Dataware as it would an operational database. For those legacy applications that already have this operational database structure, that's when the Dataware is sort of operating more as a fabric, right? So you have a single point of integration from an application to the fabric, but then the fabric manages that data as a collective shared layer. So you're not having to do all these individual integrations between applications. And so when we talk about reducing integration, we're talking about it in two places. We're talking about it on the operational side, integrating between my applications. I don't have to do that anymore. I have this data fabric that's being implemented within the Dataware layer. And then on the analytics side, I'm not having to integrate again from all of those applications some sort of repository. But the key here is just being able to support those transactional workloads. And that's something you don't see in analytics repositories that have that concept of a shared set of data. They're not there to support applications. Dataware does support applications. I don't know if you have anything else to chime in here.
No, maybe just actually 2 points just to add to that. One is the interesting thing as you start to blur the lines between analytics and operational systems is you start to realize that analytics are basically just applications, just like any other application. They use data as an input, they have some code, and they produce some type of an output, and that output you'd want to remember. So if you now kind of rethink every insight, every analytic, every prediction as a packageable business capability, just like an operational capability, well, in fact, those capabilities, we tend to think of them as, we need to have a central team that does analytics for the enterprise because of the problems. And that's why data mesh is really taking off in terms of enabling federation on just the analytics plane. But if you extend that into the operational world, then you start to be able to integrate the insights that are coming out of what would traditionally be your analytics capabilities into your operational systems. So what that, like if I translate that to more simpler terms, is you can build super intelligent applications because each of them has the ability to gain insights, not just from the data that otherwise would have been inside of the application, but from any data that it has access to via Dataware. And that is game changing because now analytics is just BAU. It's just par for the course of delivering capabilities. And the other thing is, while Dataware needs to be able to replace the use of application-specific databases, in some cases you may think of a relational database or a graph database or a document database or one or more of the above, needs to be able to absorb and avoid the need to use all those technologies directly within each application. Don't confuse that with that you need to go and replace all of your databases, because in the example that I showed earlier with Salesforce, if you're already using Salesforce, you're not going to replace it. But what you may want to do is connect it and augment it and add new capabilities to that, where you can use the extension of it to be adding not just analytical capabilities, but operational capabilities. So, however, if you're building new applications, then definitely you can avoid the creation of a new database completely.
And so sort of implicit in the conversation we've been having here about operational databases is that Dataware also serves as an analytical database. And so this is where in our previous webinar, we were sort of focused more around this capability where once your data is unified, however it may be unified, it becomes an analytics repository where as a business analyst, I can go in and I can query that data. As a data scientist, I can go in, I can view the data, I can figure out what I need, I can build features from that data. But Dataware, as we mentioned, is already this operational base. So the analytical base is present. It's not something that needs to be built out. When we look at a normal analytical base, to go back to sort of that diagram from the very beginning, we think about using integration to bring data together, right? That's sort of the bread and butter of the analytics world, bringing data from multiple sources, right? How many times have you heard that in a pitch for, data warehouse or a data lake, right? We have to bring our data together so that we can do X, Y, and Z. You don't have to bring your data together if your data is not in different places to begin with. And that's sort of the superpower with the Dataware approach is the data is not separated. It's all in one place because all of these applications are working on it in one place, which means all the data is there. What needs to be done is it needs to be made easily queryable, right? It's one thing to say sort of, I've built this complex layer that can communicate between all my applications, they can serve as this backend, but it needs to be something that is approachable too. So if I'm a business analyst, I need to be able to use the tools that I'm familiar with to go get that data, right? It can't just be for applications. It has to serve this analytical use case as well to really be Dataware. And so, that has a lot to do with how do I query that data? how do I understand that data? And we'll talk a little bit more about semantics on another slide, but that's a piece of it too, right? It needs to be intelligible and navigable to a business analyst in the same way that it is intelligible and navigable to an application. And so I think this one, maybe we can sort of see a little bit more than the operational, right? Transactional data, we talk about big volume. That's a little bit harder to show in a quick demo, but I think with the analytical base, you can sort of see some of that. So Dan, I'll let you take it from there.
Yeah, so if we go back to our network, and again, this is reflective of just our business, and everyone's network and everyone's view is going to look different based on their access. But this has things like marketing and sales and product, right? All the different domains that really form governance boundaries, because just because you can collaborate together doesn't mean it's a free-for-all and people lose control. You need that autonomy. You need, the federated governance. You need the domain-driven design approach. All the, the enablement of the ability for teams to collaborate yet work independently, and the balance between all of those things. But so, this is just really the representation of the data. But in another tab here, I'm just going to go the main screen, and I'm going to show you an example of a query that I built just earlier today, and it has the word personality. So it's revenue versus personality heat map. So what this is doing is it's basically taking all of our sales, basically any recurring revenue, et cetera, and it's extracting that from the invoice data. But for every invoice that was part of an order, that was part of a sales opportunity, that sales opportunity would have had a buyer and it would have had a seller, someone in the team that was managing the relationship and selling that. So what I've done here is I've basically created a view that shows me the percentage of the total, which adds up to 100%, where I can see the buyer's personality profiles just using the disk model. And I can see the seller's personality profile, and I can see the intersect of those two. And you can see that, for us, the sellers tend to be a captain that has its own personality traits, which I also have here as well. And on the buyer side, it tends to be the questioners at 40%. And the magic combination is captains selling to questioners. And I can add this into our lead scoring mechanism to prioritize how we navigate our funnel and whatnot. And I could slice and dice this just if I just want to see by seller, or if I just want to see it by buyer, or if I want to turn this into a chart. And this query is saved, it's shareable. But if I look behind the scenes, you can see the query is very simple. Give me the revenue, and I want the buyer personality. And notice the notation here, it's using this dot notation. So it's getting the disk archetype based on the personality of the champion, of the opportunity, of the order, of the invoice. And so that's what I like to call a joinless join. And then it's getting the personality traits of that. And then separately it's doing the same for the seller. So being able to build a query like this with a drag and drop interface is key. That's one example. And one other quick example, if I go back to that sample data set that I had created earlier, that, as you can see, the structure here is very simple, and it's a very tiny data set for just demo purposes, but you can see it has a first name, last name, it has a field called employer, which is a link, a net worth, and then a home address. And if I were to make changes, so let's say, for example, I change Jane's net worth to a much larger net worth, and then let's say then I change it to a much smaller net worth, well, that data has changed over time. So maybe though I want to actually factor in that change over time into an analytic. So there's a query that I built that took me about 5 minutes to build, and you can see it's not terribly difficult. It's 18 lines, and it's using the fact that Dataware supports the enablement of really the equivalent of a time machine, where what I'm now seeing is for each of the people that exist as rows of data, I'm seeing every iteration where their net worth has been modified. And maybe I want to do a chart of that by the name here and do it by this. And maybe I want to do let's say a sum of their net worth. And maybe I want to do that as a line chart where I can then see, if I wanted to see Jane and remove the other two, I can see there was 999 and then it went to 100, right? So being able to very quickly get intelligence out of data, but not just the present value of data, but the evolution of that data over time. These are just a couple of examples of some of the superpowers that you're able to gain regardless of where this data came from, whether it came from a mainframe, a text file, a spreadsheet, or if it was built natively inside of the platform, entered by a human. It doesn't matter. It has all these capabilities.
All right. So one of the pieces, and we've sort of made reference to this in a couple places indirectly, is this idea of active metadata, which is crucial to enabling a lot of the other capabilities we've talked about, right? And so the central concept behind active metadata is that your metadata, your data about the data, is being managed just like all of your other data. And so that's where, when Dan was showing us those changes over time, that's autonomous metadata, right? You can see changes not only to the data that way, but changes to the metadata that way. And so we can use that metadata to enable a variety of different metadata-driven experiences. Within a Dataware platform itself, sort of a couple of the key pieces that metadata is being used for in a native way is semantic consistency and editing traceback. And so when we talk about semantic consistency, that gets into the collaboration piece that we've already discussed somewhat, where I have all of these applications, I have all of these people, and guess what? They don't speak the same language, right? Surprise, surprise, two third-party developers didn't use the same terms for the same concepts. But if I'm using Dataware, if I'm trying to create this shared backend, I need to understand that a first name is a first name, whether it's called F subscore name or capital F, capital N name. And with metadata, I can start to do that. If I can understand and manage that metadata, I can create this shared comprehension, both between my applications. So as the Dataware receives requests for different aspects of the data, right? So, okay, I want a name, or, I want someone's income. That is understood as a concept separate from any particular naming scheme within an application. And at the same time, is understandable to humans, right? Because often applications use kind of unintelligible naming, right? If anyone's ever worked with SAP and doesn't speak German, like that becomes very complicated to understand what these things are referencing. And so humans use labels, but understanding both the human side and the application side requires understanding on a metadata level what these concepts actually are. And so if you're able to manage that metadata, you can start to create that semantic understanding between applications and people. And then the tracebacks for edits piece gets a little bit to what Dan was talking about, this idea of, right, to some degree, all of your data becomes time series data, right? The data itself, you have data about metadata, and that data about the data in this case is when the data changed and what the new data is, right? So I can see, in one of the early examples we looked at, Dan made a change and Salesforce made a change and ZoomInfo made a change. And I can go and see who made those changes and when they were made because I'm keeping track of that information about my data. I'm keeping that metadata and working with it directly. And while those are sort of two key pieces of metadata function that underpin a lot of the other capabilities we've talked about, the active metadata piece really is a starting point and not an end point for a Dataware platform. And so when you think about building applications, you can really think about it as building experiences, right? Where within an active metadata layer, you can use metadata to drive those experiences. This is going to become clear, I think, as we kind of look at an example of what that is. But the idea that you could build this archetype around concepts instead of specific references, because you're using this active metadata, creates for these much more flexible experiences that can change as the underlying attributes change. And so Dan, I'll let you chime in here, and then maybe you can take us through what that looks like in practice, because I know that metadata-driven experience is a little hard to visualize, just so that I could talk about it.
It's very meta. So I'll show two examples. One is kind of a human interface, and the other is a machine interface. If you have code that is interacting with that, and hopefully it also reinforces what we talked about earlier of enabling a universal unified access layer that doesn't force model convergence and all the data to be in the same location, and yet creates that unified approach, which is really the magic combination where really Dataware is kind of blending in elements of the fabric, which is often a part of a Dataware platform, and concepts around data mesh and others. But so if I go back to that example data set, this very simple data set here that just has a first name, last name, an employer, net worth, and a home address. Now imagine that we're building an application that's going to be either seeing this data or changing this data. And let's imagine not just one application, but two applications. And those two applications are built by different development teams, and they may have different models. Maybe they call them different things. Instead of first, last, maybe they have a column called full name. Maybe instead of home address, it's just address. And maybe the structure is different. Maybe the data types are different. Everything could be different. And not only that, it will change over time. So there's a couple of things. One is I've added just some calculated derived values, where here you can see it's dynamically generating a full name that concatenates the two. And we're also doing some intelligent address resolution, turning these addresses into these addresses just by embedding a model directly inside of the fabric, such that if I change this and say, I live at Cinchy. Cinchy is my home address. Then it gives me the legal address for Cinchy as an example. And I could type in any landmark, et cetera, and it will do the same. But now let's go back to I'm an application, and let's talk about application one. And I want to interact with that data as over an API. So what I've done here is I've created an API, and here, if I just show you the underlying query behind it, this is just simply retrieving some data, retrieving the full name, the intelligent address, the company, the bio of the company, and the logo of that company, and it's retrieving it from that sample data set. But it's using a model that it defined, where it called the employer field company. It didn't call it employer, it was called company. So if I execute that, you can see there's the company bio and the company logo. And whether I'm running this query through a query display like this GUI, or if I'm accessing it as a REST endpoint, so here's the equivalent as basically a JSON object being returned over REST, where similarly, it's calling that, the company field. If there was now a second application, so that was the first API. If I now look at a second API, that is a different query used by a different application built by a different development team, here they may call it employer. So the schema is different, but they both point to the same data, such that if I were to, let's say, execute this query, and if I go back and execute the other query side by side, so you can see the columns are different, but the data is the same. And if I go into the data itself, so let me go into another window here, and apologies for kind of popping all over the place here, but if I were to change, let's say, the address Cinchy here, I'll just say CN Tower, based out of Toronto. So there's the address of the CN Tower. Well, if I come back and rerun this query, it's giving me the updated value. There you can see the updated address. And here, if I go back to the other one, and sorry, now I'm losing my clicks here, then I'm again getting the updated address. So while they're referring to the fields differently, the values are the same, even though they're modeled differently. And you can take it one step further, because if I were to now further change the metadata, so if I go back here and change the intelligent address, I'm going to now call it smart address. And I'm going to rearrange it, and I'm going to, add another column here and rearrange that, and change data types. I won't do a whole bunch, but I'll just do a couple of changes here. So now I've kind of mucked with the schema, as the owner of this data should rightfully be able to do. But you wouldn't want those schema changes to break the applications, right? So if I go back to the API that was using version 1 of a model, and if I rerun that query, I'm still getting the same values back. It's still linked to the latest live data, but it's immune from the schema evolution. And the same of the version 2 API. If I just run that again, I get the same thing. It just continues to work. There's no breaking change as a result of the schema change. And not only that, one other kind of final piece here is that as the schema is evolving, so there is called the field that was called intelligent address is now called smart address. If I were to open up, let's say, a form experience sitting on top of that, so this is a human interface that's driven by metadata, then you can see that here it's still working, right? So as the schema is evolving, human interfaces are auto-adapting, machine interfaces, APIs are auto-adapting, and nothing's breaking. Yet everything can still be under the control. In this case, dev team 1. In this case, dev team 2. In this case, it's the end user. And then ultimately, it's the owner of the underlying data. They can all evolve independent, yet collaborate.
And then sort of the final thing I want to do, and I promised Kunal we would get to this eventually, but is this idea of change approval, right? Which really speaks to the data governance side of things. And so within this platform, we've looked at sort of the complexity of all of these different actors interacting on the same data. And so having a way to programmatically implement change approval, to implement data governance policies becomes really critical as this scales, right? It's one thing, I've only got a couple applications, or I've only got a handful of users that are dealing directly with raw data. It's probably not that big of a deal, but a modern enterprise has hundreds, if not thousands of applications and users. And so there needs to be a way to sort of set hierarchies of access and editing privileges around that. And so, Dan's going to take us into it a little bit more, but we already saw in some of these examples, right? Like fields that he could and couldn't edit based on who he was, right? And so that idea of change approval and data governance, we have in the analytics world around sort of different user personas that can access different things or different user rights. But with Dataware, that really also has to be extended to applications, because humans aren't the only ones going in and accessing data. Applications have to access it too. And similarly, they need to have sort of this hierarchical, okay, great, if I'm allowing all of these things, which overrides that? If I've got two different pieces of information saying they need to go here, who really gets precedence as I'm trying to rectify that uniform set of data? And some of this kind of may sound familiar if you've thought about master data management or sort of worked in that space at all, where not only trying to, from a governance standpoint, make sure that people are accessing the data they need to access and not other data, but also with the editing, that you're prioritizing the right things. You're ending up with a set of data that's being shared by all these applications. That's the right data. That's the data that you want to be shared. And so you need sort of that programmatic policy implementation to make that work. And so Dan, maybe you can show us kind of how you've approached that as you were building out the Cinchy platform.
Sure. Yeah. So if I go back to that sample.
I'll just bring up Kunal's question again to make sure we touch on that. But can data edits be routed into workflow to govern updates with approvals before being applied?
Yep. And that's a great question. So if I go back to that sample data set, this very simple one that has the first, last name, and including the home address and the changes that I made to the model, I kind of mucked with the schema. If I go into data controls, I can first of all see and change based on my ability as a controller of this data to configure those controls. I can grant or revoke access to individual users, to applications, or to groups. And you should definitely, if you're building a Dataware platform or looking to buy one, you want to look for one that integrates into your existing identity and access management infrastructure. You don't want to rebuild all of that, of course. So things like Active Directory integration and other such things. But being able to manage those grants down to, limit, can you run queries? Can you do bulk downloads? Can you see these specific columns? Can you edit these specific columns? And notice here, there's the ability for approvals and constraining inserts or deletes, or even applying row filters to get to the level where you need to be able to have a rule at the data cell level. Because, for example, I can see the salary of myself, but I can't change it, but I can see and change the salary of my direct reports, but I shouldn't be able to see the salary of my peers or my manager, right? That's a rule that should be implemented once and universally enforced. And in this data set, if I wanted to turn on change approvals, I can turn that on where it will now require that changes be authorized prior to taking effect. And for the purposes of the demo, I'm just going to leave it such that, because I'm in this group called builders, I have the ability to approve all columns. I could further constrain that. And in a real world scenario, you're going to segregate often who changes versus who approves, and especially if you're operating in a highly regulated sector like financial services. But now that I've turned that on, if I try and change, Bob's last name to L, and if I try and change J to Jane to K, and if I try and delete Joe here, you can see what it's doing is it's accumulating a bunch of changes. But if I go back to the API that I had created earlier that was using a different schema and refresh that, well, I'm still getting the same data because that data hasn't been authorized, those changes. But if I now go and let's say approve the deletion of this record, and let's say I reject, and you can have conversations in the context of the data, but let's reject this one and I'll approve this one. And that record that was now deleted is available in the recycle bin. But if I come back to this API and refresh it again, you can see I'm getting the updated value, and the one record that was removed is now gone, but it's still there in the recycle bin. And if I wanted to restore that, I can see who deleted it when. I can request the restoration of that, and that restoration needs to be approved before it takes effect. And I've now restored that data. If I come back and hit the endpoint that again is using a different schema, it's now back. So, there's a very simple change approval workflow. Often it needs to be more complicated in a real world scenario, but you would expect that if you want to enable this collaboration at scale, because it needs the controls that really databases don't have, because again, they were never designed for collaboration.
I think that's a pretty powerful example there, just to see, to Kunal's question, yes, absolutely. It fits in this workflow, right? I can have these barriers in place, even if everything is happening in an automated fashion where, I'm not allowing those overrides willy-nilly. I can have sort of a very regimented approach to data governance to access controls, both around reading and writing. So now we're almost at time. So I just want to open up these last 10 minutes for questions. If folks have questions, I know we also have some questions we didn't quite get to in the last webinar. So I'll give a couple minutes if people want to start asking questions. And if no one has anything pressing, we'll start to address some of the questions we didn't get to last time. So, we've covered a lot of territory today. We can pop back to any of that. Just if you use the Q&A function, we can get right to it. So what do you want to know? All right, I'm not seeing any questions coming in right now. So we're going to go ahead and start. Again, feel free to submit a question while we're talking and we'll get to it as soon as we can. Some of the questions we didn't get to last time, I think are pretty germane to this conversation. So if this is your question, you're here again. I'm glad we're getting the chance to talk about it. If not, I think this is going to be helpful to those of y'all who weren't here for the last conversation. But the first, given that most of us are starting off with a traditional approach, in this case to analytics, how would you transition to a Dataware pattern, right? So how do we go from, I've got all these different applications, I'm integrating them into my analytics repository to, hey, I really want to do Dataware. How do I get from one pattern to the other? Dan, I'm sure you've seen this in practice as you've sort of worked with clients. Maybe you can speak to that a little bit.
Yeah, well, I'd say start by putting all your projects on hold, hire a whole bunch of people and create a whole bunch of new budget line. No, I'm joking. Don't do any of that. Is the way is to do it such that it mitigates the risk of change, because change can't happen big bang overnight. And really the opportunity is to change how you deliver the change. The way that you start to evolve away from the traditional approach to the data-centric approach that Dataware enables is to apply it to the business capabilities that you are going to be building anyways. If you're building if you need to extract some intelligence out of your data to offer some business insight, you want to drive revenue up, you want to improve employee retention, whatever it is that you're ultimately trying to do, that's the opportunity to begin the transformation by applying Dataware as the accelerator to that project. And then when the next project comes along, do the same thing. And next thing you know it, your projects are being delivered better, faster, cheaper with less risk, but you're actually untangling your data as you deliver change. So it starts by stopping to add new silos. That's the immediate impact, but then it untangles by liberating the data as you connect it into Dataware. That data is now autonomous. It's able to be interacted with without any awareness of the underlying application. It doesn't matter anymore. So I think that's the key, is to do it gradually by applying it to your projects. Don't make a new budget line item. Don't carve out any new investments. Any transformational technology that requires you to do that is probably destined to dramatically under-deliver on ROI.
Yeah, I mean, I think that little bytes thing, right? That's not just true of Dataware. Pretty much anytime you're trying to transition, start with small projects, right? Things that you can sort of see an immediate success on. And that is true of Dataware as well. What do you want to do in the short term? Try doing that with Dataware and then expand from there, right? And so in particular, I think one of the key pieces we've talked about in a couple of points is Dataware as data fabric, right? And so that's really that workaround for legacy applications, right? I've got this sort of existing infrastructure. I don't have to get rid of that, right? I can plug it in and then I just stop expanding it. And so we do have a question that came in while we were answering this one from Tom, who asks, there seems to be a mesh versus fabric debate these days, one a decentralized model and one centralized. Do you recommend both? And so, Tom, I think this is a really interesting question. You definitely see, the terms mesh and fabric being thrown out a lot. And I think it's worth taking a step back and thinking too about what mesh and fabric are. And we touched on this a little bit in our previous webinar. But as we talk about fabric, that's much more, obviously it is a methodology, but a set of technologies, this idea of sort of a networked layer of data. And we've talked about fabric in the context of Dataware several times today. Whereas mesh is really a governance architecture, right? It's thinking about the people and processes, who is responsible for data, who owns that data. And so, the big innovation with mesh has been that decentralized model of governance, right? I have individual lines of business, individual partners that own their data and are providing that as a service, providing data products to other parts of the business. And so, I would say it's not really a mesh versus fabric debate. I think they can be done together. And Dan, I know you've thought a lot about this as well, so I'll let you chime in.
Yeah, definitely. I like this question because I think there's a lot of confusion out in the world today. Is it, the fabric is really an approach to simplifying integration, avoiding point to point, and the mesh is to enable distribution and autonomy, yet collaboration of basically analytics to avoid creating the monolith data warehouse or data lake or data lake house. Recognizing the fact that not one central team can do it for the entire enterprise as it changes over time. Well, those two things sound like great ideas. So yeah, do both. Don't do one or the other. They're not even competing with each other. And so if you think of what Dataware is doing, Dataware as a concept is not trying to address just a single piece of pain. It's trying to address the root of all of this pain, right? And the fragmentation of data is why we need to implement all of these things. So if you're building Dataware, if you're buying Dataware, you're going to want the domain-driven design approach borrowed from software architecture, where you can create data products, organize them into domains, and those domains can be governance boundaries to enable different business teams to control their own destiny, to have autonomy, control the schema, control the access. All the stuff that you would expect in a mesh. And hey, if you only have one data product because you're a small company, that's great. If you have 1,000, that's great too. Let it such that it can grow and scale with the organization as you go through, your own evolution. But when you're doing integration, don't do the point-to-point integrations. Use the fabric-based approach to achieve that decoupling of the applications. And hey, when you're building new applications, don't create new data stores. So really, you can take a fulsome approach to changing how you implement projects. Some projects need to do integration with existing systems. Some projects need to create new analytics capabilities that you don't want to have done all by a single central team, and leverage the platform to facilitate really the right sizing of the dynamic between data and codes, because that's essentially what's been upside down. And that's what Dataware is right sizing up or flipping back so it's on its feet. It is really putting the data where it belongs as a separate decoupled thing that is owned by the people, not by the applications.
And we've got a couple more questions coming in, so I'm just going to keep rolling through. Mm-hmm. Ed asks, and this is a more specific question to Cinchy and how you sort of implemented some of these things, but how does Cinchy sync with proprietary databases, read, write? Well, legacy apps are still in production, CDC, SQL code. Yep. So maybe you could speak to kind of how you've managed some of those connections.
Yeah, so like Cinchy does, as a Dataware platform, does include integration technology to basically bridge the gap between the traditional applications, be them in the cloud or on-prem, be them bought or be them built, and the enablement of the either bidirectional, single directional, or multi-directional synchronization, and you were seeing some of that earlier, is going to be largely dependent upon what platform you're connecting into. So I showed earlier the use of Salesforce, which is obviously a fairly modern platform that has, real-time, near real-time mechanisms. And but you could be connecting into a mainframe or a text file or a delimited file. And the answer is going to be highly dependent upon what you're connecting in. But that's definitely something that you'd want to be thinking about as you're thinking about your Dataware platform, is the level of interconnectivity, and does it meet your requirement in terms of ease of connecting, ease of mapping, and the ability to keep the data in sync within your expectations in terms of timeliness. Because if you need real time, you need real time. For example, if you're using Cinchy to connect to a database, you're going to use a CDC, for example, and that's not only inbound, but it's also outbound. So that's definitely something to be factoring into your evaluation of the level of connectivity. Is it going to work with your legacy systems?
Yeah, I mean, I think that's sort of a case-to-case basis for sure. But that is, I think, a really key point to look to as you evaluate Dataware platforms, right? Making sure it does work with the systems that you have in place, because everyone does have those legacy applications. And so that's a really fair question, I think, to ask.
Yes.
We've got another question that's near and dear to my heart from Jeff. I often think I should put my data into a graph, that when I look at specific examples, it hasn't made sense. How does Dataware fit with graph databases? And Dan, you know this, when I first met you and got to know a little bit about Cinchy, I was coming off of a lot of research on graph databases and this idea of networked approaches to data, which is certainly a part of the Dataware approach, right? A couple of the demos, we've seen that thing that looks an awful lot like a graph, right? That network image of the data. And so I think, kind of clarifying some of this is helpful. I think the concept of graph, when you think about interconnected concepts, is really core to Dataware, right? As we talk about semantic understanding, that's a big part of why you might put things in a graph, where you have, okay, here's this concept, here's how this concept is understood in all my different applications. That's very much a graph mindset. From a technology standpoint, right, Dataware is not necessarily a graph database. And so maybe, Dan, you can speak a little bit more on the technical side, right? What is the difference between a Dataware platform, how that's implemented versus a graph database?
Yeah, and I would say, thankfully, it's not a graph database, because a graph database is limited to really just a small set of use cases. But those use cases are where you need to leverage basically the power of connections of data to use basically the power of inference, similar to how your brain works in terms of being able to interpret data based on the connectedness of that data. So that's an important consideration. But I would want that capability not limited to a virtual or physical read-only copy of data in my analytical solution. I want that in all of my applications. I want that accessible to all of my end users. I would want everyone to be able to experience that, because you have to think of the interfacing of data via how you think of today as a graph database is just an experience into data. But maybe you want to flip in and do hardcore transactions with ACID against that. Maybe you want to evolve the schema and get the flexibility that you would expect of a document database. So today, when you're implementing kind of old-fashioned applications that are using application-specific data stores, you have to decide, is it graph database, is it document database, is it columnar, is it relational, is it this or is it that? And what you're really choosing is where to suffer, where to have limitations, not where to have capabilities. And in the Dataware universe, those are just experiences that should all be built into it so that you can get the benefit of all that, in the same way that when we draw power from our power outlets in the wall, behind all of that is nuclear and solar and geothermal and all these different ways of generating and distributing power. It's all very complicated, and they have pros and cons. And I don't need to worry about that, though. I just plug it in and it works. That's whether I'm an application or a human. I just want to plug in and it to work. And I want it to meet my use cases. I don't want to have to change the technology because my use case has changed.
Yeah, I think that's about all we have time for, unfortunately. But I think we got to a lot of the core questions there. So thank you all for joining us again today. I'm sorry we're a little bit over time, but I hope you found this useful, and there'll be a recording available afterwards if you want to go back and review any of this. Again, the recording from our previous webinar is also available, where we focused a little bit more on different analytics architectures and sort of how they match up to Dataware, what the differences are, sort of what they specialize in, and how they compare. Thank you again, and take care.
Thank you.